Welcome everyone. Thank you for joining us in this session. So as I mentioned, we will record this session. If you do not want to be in the video, please turn your camera off, and we advise you to put your microphone in mute while the presentation is happening. So welcome. As part of this Open Science initiative, this campaign is intended to bring awareness of pre-registration and other open research practices necessary to ensure transparency in the research workflow. My name is Guzman-Ramirez, and I am the Research Data Steward for RSM and ESE. And together with Mutaleni Nadimi, for a project manager from the University Library, and Antonio Schettino, the Open Science Coordinator of the Erasmus Research Services, we're very happy to welcome you to this session and the whole campaign. Also, if you're interested in open science, please consider joining the Open Science Community Rotterdam, where researchers and support staff help each other in learning, discussing, and adopting open science practices. For more information, Mutaleni will put the link in the chat. So we welcome to put questions either in the chat, or you can raise your hand by when the session. I guess, well, if you want to make this interactive, because it's going to be a little bit interactive, you feel free to raise your hand in between the session and I'll give you the floor. So today we're joined by Aurélie Lemmens and Martinovici. So Aurélie Lemmens is an associate professor of marketing at the Rotterdam School of Management. Her current research focuses on the development of predictive and prescriptive analytics to address key business decisions and to the fairness of the algorithms used to design and evaluate policies. On top of that, Aurélie Lemmens is the winner of the ERIM Open Science Award 2021. Anna Martinovici is an assistant professor of marketing at Rotterdam School of Management. Her research focuses on the role of attention in consumer choice processes and has an extensive experience using Git. Thank you both for being here today. I'll give you the screen to present. Sharing.
Can you see my screen?
Yes, thank you.
Great. Yeah. Cool. Yeah. Okay, great. Thank you very much, everyone, for joining. Anna and I are very happy and pleased that we are able to present our thoughts about open science here in this presentation. So it's really an honor to be here. And we wanted to make it a little bit of a hands-on kind of presentation where we show you, like in real life, Anna and I do try to apply open science the best way we can. And so this is a bit more practical maybe than some of the other sessions that were before, and I hope you can learn something from it. So before we start with the practicals and the little advice we want to give you guys about how we can apply open science, I wanted to reflect a little bit on why we thought open science is something that's important for us. And actually, the best analogy I found is the analogy with the second-hand car market, right? So this is a typical market where there is a lot of information asymmetry. Because we don't know most of the time what's the value of the car that people are trying to sell and people want to buy, right? So it's a little bit like with in science with authors and reviewers, basically, right? Where the seller will be the author and they basically wanna tell that their paper is great and people should accept the paper into a top journal, and they don't really have a lot of incentive, if you think about it, to be completely transparent about the things that happen during the publication, during the writing process of the paper in the current situation as we have it today. It's a bit like the sellers of a car, right? They're trying to hide some information to some extent because they want the car to be sold. And on the other side, the reviewers or the buyers tend to be a little bit frustrated because they have only limited information about the article or the car, and they need to make assumption whether this is a good car, whether this is a good article, right? So this is very problematic because this information asymmetry leads to a lot of lack of trust, which makes everyone very demotivated. I think as a reviewer, we all feel sometimes that we don't know to what extent we can trust a paper, and therefore we're going to sometimes pay attention to things that maybe we should not pay attention to, like p-values or this very minor stuff. And that prevents us from looking at what is really important, because, for example, the evidence of the strength of an effect that you could find across many different studies. So that is why we think that maybe transparency, we hope transparency can be a solution to this problem, because we can remedy to this information asymmetry and actually help both the authors to feel that they can reveal all the information about the research process, and then the reviewers to feel confident that they have all the pieces of information to evaluate how strong the evidence about the specific effect is. So I think that's for me something nice to keep in the back of my mind when I want to be open as an author or even as a reviewer in the process. So basically the move from open science to from closed science to open science allows to have more information symmetry, and hopefully will help all of us to move from a mindset where we're going to start counting the publication, looking at significance level, to think more globally about how interesting a paper is and how strong the evidence is into these papers. So I think it helps a little bit to motivate ourselves to go into that direction, to realize how important that is. So like I said, in this presentation, we want to try to make it as practical as possible. And we are not going to focus so much on the first stage of the research process, which will be the elaboration of the hypothesis and the research question, because this is something that has been done a lot in the previous session of this campaign. So we're not going to talk about pre-registration. We're going to talk about what happens after, when you collect the data, when you do the analysis, and maybe when you want to move to automation. So I will tell you something about how I think people can share the data even when they are under NDAs, and where you might think a priori, maybe I should not share my data. I'll explain you a way you can do that. You can still do that. And then I would like to say something about how you can make your code public and maybe more easily accessible and reusable by other people, in a spirit of open science, but also in a spirit of getting more impact by, in the real world, having people actually using your work. Then Anna is going to take over. She's going to tell you more about version control and GitHubs and automation. She has very nice ideas of people can make their work more effective and automate it along the process. So that's the agenda for today. So let me directly move to the concept of publishing data. So I think many of you, and I was also one of this person, believe that because we were working with company data, at least that was my case, I was actually not being able to share this data, and I should not be someone who can actually contribute to open science. And then I realized some years ago that actually that's not an excuse, that actually even when you sign a data sharing agreement with a company or with a third party, you can still, under some condition, share some version of this data. And that's what people call synthetic data. Okay, so there are some packages that actually help you to transform your data into something that you can share with the public. And there I want to put directly a little disclaimer, and I think Lisette maybe can say something about that after the presentation. It, of course, depends a little bit on what type of contract you exactly sign with the company. And but if you go for the traditional contract that RSM is providing you via, for example, Violet, you can actually be confident that you can share synthetic data with the public via a website or via GitHub or via another platform. So always talk first to our data advisor at the university, but most of the time this is possible to share synthetic data. Okay. So how do you do that? So basically the idea of those packages is very simple. You generate data that very much looks like the original data, but are not the original data. Okay. So on average, they will share the same properties as the original data, but they will not be like the original data. So for example, I was taking there the example of a construct of interest that you're interested in measuring. For example, here beta head, that will be measured on the original data set. For example, suppose in my own research, I want to measure price elasticity. Okay, so what you can do with those softwares that I'm going to describe in a moment, you can actually generate new data sets, synthetic data sets, and you usually generate multiple of them, like I call it M, so M different synthetic data sets. And on average, on each of these data sets, you will estimate a beta parameter, which is similar to the original one. And the average of those betas will actually be equal or very close to the beta that you have estimated on your original data set. So this is amazing because it allows you to actually publish this data set on GitHub, or when you, for example, when your paper is accepted, you have to send some replication files. So you can provide one of these synthetic data sets, the people are able to actually replicate your results, but you are not sharing the original data. So I think it's very interesting tool for all of us to use, and basically means that we don't really have an excuse anymore for not sharing our data, right? I think that's an important point I wanted to make. So this is one of the packages that you can use. It's a very nice article that I would like to encourage you to read if you have the time. And basically what the paper assumes is that your observable data set comes from a population that the synthesizer is able to estimate. Okay, so that's the first assumption. Of course, if you cannot do that, then you will never be able to generate synthetic data that look like the original one. But the good news is that these packages and other packages actually include a lot of different models that you can use and try to see which one will fit better your original data. And I can tell you by experience that usually you get to something very close in terms of these beta parameters that you estimate. So you can choose any model you want. You can find your favorite model, for example, boosting, ensemble models, whatever you want, and generate your original data, generate synthetic data that looks like the original data. So how does it work? I'm not going to go into the technical details, but just to tell you a little bit the intuition how that works. Basically, the software takes all the columns of your data sets, and for each of the columns, you're going to estimate a new column for your new data set, for a synthetic data set, based on all the other columns of your data set. Then you move to the next column, and you're going to do the same thing and include the new column that was just generated, and you generate again the new column, and you go on like this until all the columns have been generated. And this is how you get your new synthetic data sets. You do that m times, meaning that you're going to get m new data sets that look like the original data set. So again, super simple. It takes a few seconds in R. Basically, you just have one line of code. You just have to load the package and then write on that line of code. And then you can see on the right, this is what I did on my dataset for the last paper that I got published, where you can basically see with the synthesized dataset, that's the light blue, and the original dataset, that's the dark blue, that the distribution of my covariates are actually, so all the columns are actually very similar to the one from the original dataset. So it costed me really 5 minutes. And then I have this new data set that I've been there. So it's really, really nice tool to be using. Okay, how much time do I have? Okay, good. So now very quickly, I would like to also say something about the code. So it's not just about the data, but I think it's also very nice if you can share your code with the community and hopefully getting some third parties, like in my case, companies using this code. So I've been also trying to do that only since a few years, and I realized how nice it is to be able to share your code with other people and having people actually sending you email to ask if they can use it and ask for advice. And actually, this is not so difficult as it might feel, right? If you are already able to write some R code yourself, this is just a few extra lines of code in order to be able to now make it a nice package. So I just wanted to use a very small example to show you how simple this is and make sure that you don't get scared anymore to do this kind of extra steps for open science. So the first thing you have to do is just to download some two different packages, the DevTool packages and the Oxygen 2 packages. And then you just basically create a package of choice, right? So here I set up my directory, and I will tell you in a moment, I shouldn't be doing it like that because now I'm using the path from my own computer. I shouldn't be doing that, but I just did it very quickly. And then I just choose a name for my package and decided to go create my first package, right? That's the package I'm creating today. By the way, the slides will be shared if you want to have a look at it later. And then what do? I generate my code, which is basically here a few lines of code, like you always do it in R. But what's different now is that I'm going to add a documentation, right? So these are the few lines before that start with the hashtag. So you just add these few lines of codes to generate the documentation for your package. Okay, that's also very simple to do. In the end, you just have to add the documentation to your package by writing up DevTool document parentheses. And that is very nice because then in the end, when you check if your package works, you just get this very nice documentation here on the sides that looks very pretty, that actually illustrate what your package can do. So you see just a few lines of code, super easy. If you can program in R, you can very easily do that. It's really not so difficult to do. So I hope this will encourage you to also, share your data and share your code. And I can guarantee you that if you do that, you're going to get a lot of people sending you email and calling you because they want to use your package. I found that very exciting and made my work more relevant to what it was before. So now I would like to give the floor to Anna to continue with the rest of the presentation.
Hi, everyone. My name is Anna Martinovici, and I'm here to persuade you to make GitHub fun. So this is going to be an extremely brief intro into Git, GitHub, and Make. Okay. So I hope that after this workshop and after many other workshops, this is going to be your reaction when you see that someone is not using version control. And especially if that person is in charge of simulations behind public health decisions during a pandemic. So the code that this person is referring to, thousands of lines of undocumented C code, was used by the UK government at the time and also by other governments to make public health decisions. So yeah, start early, start using version control from the beginning of your project, and don't wait for 13 years before you properly document your code. Now, I mentioned Git, GitHub, and Make. So what am I really talking about? What is Git? It's a formal version control system. It's been developed and it's being used to manage the source code for Linux, among other things, but also regular people can use it to track content in their projects for source code, data analysis, websites, and so on. What is GitHub? This is the home, one possible home for your Git repositories. It's also a very nice interface to explore public Git repositories, and to a certain extent, under certain conditions, it can be a safe place to keep your code and data. It also has some additional benefits such as issues, projects, wiki insights. So I would recommend people who have questions about the package that Aurélie is sharing on GitHub to not send her emails, but to open issues. So why? Why should we use version control or Git and GitHub? It makes it easier to explore code, to track issues, to learn from others. It really lowers the barriers to collaboration. So instead of sending an email to ask something about the code, you can really have even a pull request. Here's a correction to your code. And very important, it is free for researchers and students. So if you're thinking that you should be using GitHub, well, how? This is the link to materials, including a recording from a workshop that I gave last year at SIPS. You can also sign up for a workshop that I'm going to give in April. That's going to be a lot more hands-on, and you'll actually get to practice things. So now let's do some live coding and show you how this works. For this, I will go to GitHub. The GitHub Fun repository is the one that you can use also to get access to some other resources that can help you learn more about version control and also Make. So I'm going now to show you how to clone this repository. I'm opening RStudio. I'm creating a new project with version control, with Git. I'm copy pasting the link to my GitHub repository, and I create the project. This clones the repository from GitHub locally. It creates a local copy. And it opens it in RStudio. What I want to show you today is an example makefile. So I will switch the branch to example makefile. As you can see, you can also use this point and click interface. Of course, you can also use the terminal to do exactly the same steps as I've done before. So let's see what this makefile is all about. Well, Make is a tool that can help you automate your projects, meaning that Make will remember what needs to be done and in what order and what depends on what. So you don't have to use your brain and you don't have to use your limited memory, working memory and cognitive abilities to remember what file depends on what file. You just write it in the Makefile. And for this example project, we're going to do something rather easy, but this can very much scale up. So in this example toy project, we have a raw data set. We have a script to process it, which will produce a process data set. And after that, we have a script to analyze the data, which together with the process data will create the results. So this is what the makefile says. All you have to do is analyze the data. How do you analyze the data? Well, that depends on the process data and the script to analyze it. So you're going to analyze it. And how do you process data? Well, this depends on the raw data and the script to process the data. And you're going to use this R script to generate it. So now, if you take a look at the structure in this folder that I have locally here, I have a makefile, I have data, I have SRC where I have the scripts that process and analyze data, but I don't have anything else. So now I will type in the terminal make. That's the only thing you need to remember. Enter. This creates a folder, TMP, that's the name I chose, where I save the process data and I get my data summary. So there we go. If I click, I see the result. Obviously, you can also produce tables, you can produce any kind of output you're interested in. So now, if I type again make tells me there's nothing to be done because I've already built everything you want in this project. Okay, but then what happens if, let's say, I change the script to analyze data? Well, if this happens, then I need to redo my results, but I shouldn't reprocess the data because the process data does not depend on my script to analyze it. So let's try it out. I will open the script to analyze data. And let's say I change my mind about how I want to name this graph that I'm saving. So data summary, new name. Please do not do this at home. Use more meaningful names for your object. So if I go back to the terminal, I can also type make-n. What this command does is just print what should be done, but without executing anything, which can come in handy if you have, for example, very time-consuming computations. You first check what needs to be done, and then you can decide, okay, is this the right time to do it, or maybe later. So I see that I need to redo the analyze data target. So if I just type make, I'm going to get my new results. Of course, you can also add commands here that would delete the previous results to keep things clean and tidy. There are all sorts of options to make this very nice. And one final thing that I'm gonna show you now before we stop for the questions. Let's go to change the create process data, because if I modify the script to process the data, then everything should be done again. So create process data. Make is very, very sensitive to any change. I'm only going to add a new empty line. So make, okay. It needs to do everything. It needs to process data, and it processes the data. So this kind of tools can really save you a lot of time in the long run, because you don't have to remember what needs to be done, when it needs to be done, and so on. You only specify it in the make file. And this was the very brief example. I hope it made you curious about make and version control. And if you are curious about these tools, then I do recommend you check the GitHub Fund public repository for links that point you to other information that can get you started with makefiles. And next step would be Docker. Thank you.
Thank you so much, both of you. Thanks a lot for that. Are there any questions from the audience? Sorry, yes, Antonio.
Yes, unless somebody else has other questions. So thank you. I mean, both of you, yeah, have very, very nice, you know, also technical skills. So my question, so you can imagine that, you know, these are technical skills that not everyone might want to learn or might have the time to learn. But this is not necessarily a bad thing, because maybe they could start collaborations with you or people like you, so that, you know, there can be this added value to the project. How is your experience with these kind of collaborations? Like, do people, you know, like ask you to collaborate because of your technical skills?
Well, it didn't really happen so far, I would say, that someone would really reach out to me because of this technical skills. But I would be happy if this happens in the future. And in terms of like the time that it takes to learn how to use these things, I'm teaching version control to all of the master students. So I have 2 courses. I teach students in the marketing management program how to use version control. They don't have a technical background and they can manage just fine. So step by step, everyone can do it. Aurélie?
Yeah, and you don't need to do everything at first, right? I mean, we also learn very slowly. So I think it's good to select what you think is most relevant for yourself and start with that. And then you'll already be happy with that, and then you can move on to the next step. And indeed, I think it's nice to collaborate with people who already... I had that a few times, people who asked me to join a project because more of the technical skills. And then it's also nice for me because then I can learn the other type of skills, you know, that from this people.
Thank you. Andreas, you have a question?
Yes, thank you. First of all, I fully agree to take small steps, start with something simple, and you can always add more complex steps in the long run. But I don't have so much of a question, but rather shamelessly plug some R package of my own for synthetic data generation. So I've done some work on that during my PhD, and few years after that, my co-authors really ran with it and made it much better. And they also have a paper in the Journal of Statistical Software. So I just wanted to mention it, put it, the paper in the chat. And what we focused a lot in this package is like also simulating household structures. So it's mostly designed for household surveys and these kinds of things, where you first want to simulate the household structure and then simulate other aspects of your data. So I just wanted to mention that, and sorry for just plugging my own things here.
No, thank you. This is great. So just to tell you, everyone, we will share after the presentations to everyone that signed in. So there are people that couldn't join the session, but they're still signing for the session. We will send the slides, links to these things that have been shared, also the session that Anna will do in April, so if people want to sign in, and the recording. So we will share these things. Thank you for sharing them to us as well. We just go to 10:30, but I still need to ask you one final question, Anna and Aurélie. So if you had to choose one open science practices that is necessary to ensure transparency in your field, what would that be?
You can go.
Version control with Git and GitHub, not version control on Dropbox. That is not version control.
Okay. Aurélie?
Yeah, for me, I think something that people, I think, tend to forget is the documentation. Of course, you cannot have just the documentation, but if you share everything, you know, everything you have, your data and your code, but then it's not documented, you cannot do anything with that. So I think spend time on documentation. That's what I would like to say.
Excellent. Thank you. Thank you so much, everyone. Thank you, everyone, for joining. Thank you, Anna and Aurélie, for this great session and very interactive. Thanks a lot. That was very nice. We hope to see you in the next session. Sarah Mutaleni will put the link for the registration if you want to join on the next session. We still have 2 weeks to go. Yeah, thank you, everyone. Have a great beginning of the week.
Thanks.
Bye.
Thank you.